Hello everybody, it's Mr. Ray with our next lesson in grade 11 University Math. We are working in the rational expressions unit right now. In the most recent lesson, we learned how to simplify rational expressions, and today we're going to look at how do you multiply and divide rational expressions. So just as a brief recap, what is a rational expression? A rational expression is like a rational number. A rational number is just a mathematical name for a fraction. But a rational expression can have variables in it. And so the formal definition, rational expression is a fraction where the numerator and denominator are both polynomials. Since polynomials and rational expressions have variables, special consideration must be given to ensure that the denominator of the rational expression does not equal 0, because if it did, we'd have some serious problems. Divide by 0 is an error that you can't overcome. So every time we either simplify or multiply or divide rational expressions, or in the future when we add or subtract, we'll give our answer, but we always have to do state restrictions as to what values the variables involved cannot be, because if the variables were those values, it would cause a divide by 0, because the denominator would be 0. Okay, now in terms of the polynomials, we said there's it's like a fraction where you have polynomials on the top and the bottom. Those polynomials could be any level of complexity. You could have just an integer. You could have like a linear expression. You could have quadratic expression, and higher. And it could be in the form of just like an expanded polynomial with no brackets, or it could be in factored form, or it could be somewhere in between. So you have to be able to expect just about anything. Okay, but we'll go through the process how we're going to multiply and divide today. Now, before we get into some examples, I want to kind of compare how this is going to work with rational expressions compared to just rational numbers. So if I just had, I'm going to use these capital letters as my, these might be numbers. If these were numbers, these would just be two fractions. So if we have these two fractions or two rational expressions, P over Q, R over S, and we wanted to multiply these two together, if they're just numbers, we just multiply across the top, multiply across the bottom, and get our answer. Now, it could be that instead of just having numbers here, we might have an expression like x plus 3 or x squared minus 10. So we still multiply those expressions across the top or bottom, depending on where they are. And so the process works the same as it does with fractions. Now, the thing that's different about rational expressions, which we mentioned earlier, with a rational number, your numbers are there and they're constants. So you won't have a constant of 0 on the bottom, so you never have to worry about restrictions on variables because there are no variables. Now, with rational expressions involving variables, obviously, it is possible for the variable to have a value that would cause a 0 on the denominator. So again, we have to watch out for that. Something we didn't have to do with just regular rational numbers. Okay. Now the other thing, so in this case, when we multiply across, P over Q times R over S is equal to PR over QS, and the restriction would be Q and S cannot be 0. Both of them can't be 0. Okay. So that's basically how we do it. So to multiply rational expressions, again, just like we did with when we simplified, the first thing you do is you factor anything that's degree 2 or higher. You're going to factor, and in fact, you could actually common factor anything. So you're going to go through the whole factoring process on the top of each rational expression and on the bottom. So come up with your factors. And then once we've got them all factored as much as we can, we're going to multiply the numerators together to get the solutions numerator, and then multiply the denominators together to get the new denominator that goes on the bottom of the solution. At that point, we're going to cancel any common factors, just like we did when we simplified, and then state the restrictions. And we state the restrictions before we cancel anything, any factors, because any factored expression on the bottom, any canceled factor on the bottom is still a concern, because if that canceled factor was 0, you'd still have a divide by 0 issue. Okay, so I want to go back to when we divide fractions or rational numbers and remind you of how that works. So if I had a 1/2 divided by 3/4, hopefully everybody remembers, we turn this into a multiplication problem by we keep the first rational number the same, but we change the operation to multiply, and we flip the second rational number upside down like that, and then we multiply across. Now, don't forget, we could cancel. You can cancel and reduce the 2 and the 4, or you could just say, I'm going to wait, multiply, and I'm going to get a 4/6, and then I can divide top and bottom by 2 and get my final answer of 3. But the important thing was remembering how do we handle division of 2 rational numbers, because that's exactly how we're going to do it with rational expressions. Okay, so down here for rational expressions, same 2 that we had above, P over Q and R over S. If we want to divide P over Q divided by R over S, you can see I've kind of left out a step here where I flip it and change it to a multiply, but that's going to equal P times S over Q times R. Okay, that's going to be your answer when you divide. And let me just look at it. I think there's a little error here. Because obviously Q and R can't be 0, because that's on the denominator. But actually, there is a typo here. S can't be 0 either. And that might be a surprise to some of you, saying, well, why is that a concern? S isn't even on the bottom of the answer, but it was on the bottom of the original question. Okay, so the Q, the R, and the S. So when I'm looking at this expression here, basically when I do my restrictions, I'm looking at 3 of the 4 cannot be 0. The only thing that could be 0 is the P that's on top of the numerator of the first expression that that's in the first position. So all 3 of these cannot equal 0. Okay, I'm not sure why this does not show an S. I think that was dropped from a previous version, but all Q, R, and S cannot equal 0. And then we go through the process. This should be pretty familiar. To divide rational expressions, again, factor any binomials and trinomials, and higher, obviously. You do any type of factoring you can. Common factor, trinomial factoring, simple and complex, and also difference of squares might be there. So you've got to go through all the possible factoring and get each of those 4 expressions as factored as you can. And in some cases you can't factor it, so you just leave it as it is, and that's fine. Once we've factored all the possible expressions, then we multiply the reciprocal of the divisor. That's just a fancy way of reciprocal is R. The divisor is what you're dividing by, so that's R over S. Reciprocal of R over S is S over R, so we're basically multiplying by S over R. And then once we've got our combined answer here, the PS over QR, if we have any factors that are common on the top and the bottom of our answer, we cancel them out. Okay, and again, do the restrictions based on if you have any variables in those positions of your question. None of those factors that are there are allowed to be 0. Okay, so let's do some examples. So our first question, simplify 3a cubed over 2b squared times 10b cubed over 9a squared. Okay, so now here's the important thing about multiplying. Just like when we multiply rational expressions, it's the same as multiplying rational numbers. You do not have to have a common denominator when you're doing this. And that's why we're doing multiplying, dividing first, because we don't have to worry about denominators being the same. When we do adding and subtracting rational expressions, we do. So I see lots of students, they'll get very fixated on common denominators, and they might think, oh, I've got to do a common denominator here. And you know what? If you do it and you do it correctly and simplify it at the end, you'll get the correct answer, but you've just made the question 5 times harder than it should have been. And when you make a question harder than it should have been, there's a good chance you'll make a mistake or two along the way. So multiplying, dividing rational expressions, you do not need a common denominator. And there is no mention of that up here, but just a reminder that you don't have to do it. We can go straight to the multiply. Now in this case, we've got a monomial in all 4 positions. So I can't really factor anything out of there. So what I'm going to go ahead and do is just show what we're multiplying. So it's basically, so I'm multiplying 3a cubed with 10b cubed. So I can multiply the 2 numbers together and get a 30. And then the a cubed and the b cubed, I can't create a single term from that. At least combine them together. So I just multiply them as is. Okay, if that had been an a squared, I could have combined the a cubed and the a squared, but that wasn't the case here. So the numerator is 30a cubed b cubed, and in the bottom we do the same thing. I do my my constant multiplication first. 2 times 9 is 18. And then I've got my b squared and a squared. And I like to keep the variables in order if I can. So I'm just going to change the order that it was given to a squared, b squared. Okay, now at this point, this is where we're going to simplify. So there's really no factors that are showing here. You could think of, you know, I could put the 30 in brackets and the 18 in brackets and the a cubed, a squared. Think of it that way, that those are the factors, but you don't have to like you would do if it was a binomial factor. You just have to remember your exponent rules when you're when you're simplifying this part with the variables. The 30 over 18, that's just like reducing the fraction 30 over 18. I can divide both of those by 6. So when I divide by 6, I get a 5 on the top, 3 on the bottom. So those will be part of my answer. Okay, and here, this is where you do your exponent rules. So I've got a cubed divided by a squared. So basically what you do is you think of it, you just do a subtraction, the exponent on the top, subtract the exponent on the bottom, so you're left with an a. And basically same thing for the b. 3 minus 2 gives an exponent of 1. So I don't have to put the exponent 1, I can just put ab. So that's my simplified answer, my final simplified answer, but I do have to do the restrictions. Okay, and I'm going to change it up a little bit from the way we did it in the last lesson. I basically said, okay, before we start canceling things, which we did here, do your restriction. Now, I was just making sure you knew you had to do it before you started canceling stuff. Okay, all you have to remember is I have to go back to this step and look at what's on my denominator to know what I should restrict. So this tells me that a squared can't be 0, b squared can't be 0, or I could look at it as a times b times b. So we know that a can't be 0 and b can't be 0. So if you see any power of a variable on the bottom, you just know that that variable can't equal 0. So the way we'll put that is a can't be 0 and b can't be 0. That's our restriction. Okay, so that was a fairly simple multiplication of, you have monomials on all 4 positions. Let's try something a little tougher. Excuse me. All right, so now we have some more complicated rational expressions. We actually have polynomials. We have a quadratic on the top and bottom of the first expression and a linear on the top and bottom of the second. So the very first thing we have to do is factor, which we didn't have to do last time. So I'm going to leave it as a multiplication for now. Now the monomials, the binomials over here for the linear, you would see if you could do common factor, but in this case there's no coefficient for the x, so there's nothing we can factor there. So I'm actually going to leave them the way they are, but I'm going to put them in brackets just so they look more like factors, because they are factors, but there's no brackets required if it's just one factor. You can just, so I like to put the brackets around because it reminds me, oh yeah, I've got to think of these as factors now. Okay, now over here, these are both trinomials, simple trinomials because of the 1x squared. So we're going to do our simple trinomial factoring for both. And again, just like we did with our simplifying, I don't want to see any factoring process over here. If you need to do factoring, you do it over here. You basically factor it, you get your factors, and you plop them in over here, and then we just work on it. I'm going to do this in my head. I'll talk through it. So I'm looking for two numbers that multiply to -6, add to +1, so I know that's +3, -2. So I've got +3, -2 on the top of my two factors. And then at the bottom I've got two numbers that multiply to -15 and add to +2. That's going to be x plus 5, x minus 3. If you have to do that, if you can't do that in your head, please do it on the side as a sidebar. Like I said in the previous lesson, I'm not even going to be checking your actual factoring if you have to write it down. All I'm checking is that you get the factors right. And obviously if you get the factors wrong, the rest of the question really doesn't mean that much because everything's wrong beyond that point. You can't correct it. If your factoring's wrong, the whole rest of the process is wrong. Okay, now what I could do at this point is I could just combine this into one rational expression. Since I'm multiplying, this rational expression with this, I could rewrite it as just x plus 3 times x minus 2 times x minus 3 on the top, and then x plus 5 times x minus 3 times x minus 2 on the bottom. Basically, remove the multiply sign and put the whole division bar. I could do that. You don't have to. As long as you realize at the next stage, what we're going to do is start canceling factors. So immediately I see I've got an x minus 3 here and an x minus 3 here. So I'm going to put a line through those. And also have an x minus 2 here and here. And that cleaned up quite a bit. So I've really only got one factor on the top, one on the bottom. Now in your final answer, I don't really want to see the brackets. Since it's just x plus 3, you don't have to have brackets. And I like to think as simplifying as no brackets in your final answer. So this would be the final answer. Now we still have to worry about restrictions. Excuse me. Okay, so you can see we're starting to do restrictions a little bit more in our heads at this point. I'm not doing a big restriction stuff process up here and then just copying my answer down here. I'm going to think about it now at this point, even after we've got our final answer. So remember, I have to think about restrictions before I canceled anything. So I just kind of imagine on the bottom here, none of these can be 0. Okay, even though I've canceled 2 of those, all 3 of them could never be 0. So when I look at the values that would make each of them 0, I've got a -5, a +3, and a +2. So I'm just going to put that here and try to put it in ascending order. negative 5, 2, and 3. So those are the restrictions. They would cause, obviously when you look at your final answer, you're thinking, well, the only thing x can't be is negative 5, but because we canceled some factors to get here, we still have to consider those factors not being 0, because, you know, if you actually plugged in x equals 2 up here, you would get divide by 0 twice. So we can't have that. So we're going to leave it, we're going to consider all the restrictions before we canceled for the denominator. Okay, so that was a more complicated polynomial rational expression where we actually had to do some real factoring. The next question here is our first division. So we're going to divide this rational expression. And you can see in this one I've got, again, just monomials. So I don't really have to do any factoring. Now remember, so the first thing I'm going to do, since I don't have to factor, is just change it into a multiplication question. So 2ab over 5c times, and then this rational expression, I take the reciprocal, flip it upside down. So I now have 15c squared on the top, 14a squared, b squared on the bottom. Now I can combine, just multiply the tops, multiply the bottoms. So when I do that, I get 2 times 15 is 30. And then I've got an a, a b, and a c squared. So a, b, c squared on the top. On the bottom, I've got a 5 and a 14, so multiply them to a 70. And then I've got a squared, b squared, c. Notice how I'm putting them in alphabetical order. And the reason why I do that is so I can compare them a little easier. I'm not hunting for its twin on the other side of the division bar. Okay, so now we can actually start canceling stuff. So the first thing I look at is the constant part. I have 30 over 70, and I can very quickly see that I can divide both of those by 10. So when I divide 30 by 10, I get 3. 70 divided by 10 gives me 7. And now I'm going to look at, well, let's just do this. So I know I've got a 3 over 7, which was the 30 over 70 simplified. Now when I look at the a over a squared, there's a couple ways you can do this. And hopefully you'll do it the quicker way. But you could do it the old-fashioned, what's the exponent of the top minus the exponent of the bottom of that variable. So it'd be 1 minus 2, which would be negative 1. So you could put a to the negative 1 up here. But the quicker way would be just looking at, thinking about, well, how many a's am I multiplying on the top? Just 1. How many a's am I multiplying on the bottom? 2. So if I cancel that a out with one of them from here, I'm left with a single a from the bottom. And then similarly for the b is exactly the same as a. I've got b to the 1 over b squared. So I've got one extra b that I'm multiplying on the bottom. So that remains on the bottom. And then the c squared is the other way. I've actually got c squared, which is c times c divided by c. So when you cancel a c from the top and bottom, you're left with one remaining c on the top. So that would be the final answer, simplified as far as we can. Now, in terms of the restrictions, this is where we have to be careful. So remember, you don't forget that this was a division question, right? So when it's a division question, remember 3 of these 4 parts. 3 of these 4 parts, you have to make sure that those terms can't be 0. So I'm looking at the 5c can't be 0, the 5c squared can't be 0, and the 14a squared b squared can't be 0. The only thing that could be 0 is 2 times ab. That's never going to cause a problem with divide by 0, but any one of these could. Okay. Remember, the 15c squared was originally on the bottom of the division question. So that's why it can't be 0 either. Okay, so when I look at each of these, okay, I can see that, well, since I don't have any binomial factors, I'm just looking at what letters are involved here, because if any of these variables, A, B, or C, were 0, I would have a problem. Okay, the C would cause both of these to be 0. The A or the B being 0 would cause this to be 0. So all three of them can't be 0. So A is not 0, B is not 0, and C is not 0. Okay, if you want to put A comma B comma C not equal to 0, that's fine too. I like to do it that way though. All right, and then we get to our toughest question, as usual. We have a division question with a bunch of quadratics in the rational expressions. So the first thing we're going to do before we change it to a multiplication is do the factoring. So I'm going to keep it as a division for now, and then do the factoring. So all of these are simple trinomials. So I would expect all of you to be able to do this in your head. There might be one that you can't quite think of what the factors are. So maybe you do a little calculation over here to figure it out. But again, never show your factoring work here. So I do know that the top, it's going to both binomials start with x. Just zoom in a little bit. Okay, both factors start with x, and the two numbers multiplied to -20 add to -1. So that would be a -5 and a +4. So those are the two factors of that. Now the one on the bottom here, I realized, okay, that's not a trinomial, but it's, it's a quadratic, and I can see that I could factor the x. That would be the greatest common factor. So I can write that as x times x minus 6. And like I've said earlier, I kind of like to have anything, even if it's a monomial factor, put it in brackets so you can see all the factors are nicely in brackets, and you can you can point them out very quickly. So this quadratic, simple trinomial, so both factors start with x and multiply to 20, add to 9. Well, that's 5 and 4, both positive. And then on the bottom, I've got x first place, two numbers that multiply to positive 36, add to -12. Well, that tells me both numbers are negative, and it's going to be -6. -6 times -6 is positive 36. When you add them together, you get -12. Now, you could put, legally you could put this as x minus 6 squared, but I would prefer if you actually wrote both of those same factors out twice, because there's a pretty good chance you might want to cancel one of them, but not both of them. So that's why you leave it without the exponent if they're the same. Okay, now at this point, I'm going to flip the second rational expression, because we're going to change it into a multiplication question. So the first rational expression is unchanged from the previous line, but now we change it to a multiplication. So now I'm putting the x minus 6's on the top, and the x plus 5, x plus 4 on the bottom. Okay, and I actually, I could have put this, like I talked about earlier, I could put both of these, parts together without the multiplication sign. It's not necessary to do that. We will eventually combine them in the final step, but that would be acceptable if you went and put them all together. I kind of like to leave them separate to show that, well, look what we did here. We changed it from divide to multiply, and now we're going to cancel. So you just start hunting for factors that are common on the numerator and denominator, and just as I expected, we have an x minus 6 on the top and bottom. I've got an x plus 4 top and bottom, and I think that's it. Always do a pretty good check here. So that is in fact all that we have. So now I'm just going to do my combined rational expression with what's left over. So I have an x minus 5 from there. I have an x minus 6 from the second part. And on the bottom, I've got x over times x plus 5. Okay. Now, a lot of teachers are pretty okay with leaving it like that. I would like my students to actually multiply this out, because what I said earlier, what the word simplifying, and that simplify is the verb that was put up here. Simplifying means combine like terms and get rid of the brackets. So I actually want you to expand this. Okay, so when I multiply these two together, I get x squared, and then I have minus 5x minus 6x, that's minus 11x, and then negative 5 times negative 6 is plus 30. So I've done my multiplication of the two binomials to get a trinomial here, and here it's just x squared plus 5x. So that is the final answer, and it's simplified as much as it could be. Now, we have to think about restrictions. And this is going to be the most complicated one so far. So let's talk about what x can't be. So the line that I'm looking at now, I could either look at this line or this line. Either way, I'm basically saying every factor in this second expression can't be 0, and the denominator of the first one can't be 0. So I could just say, this kind of L-shaped box. Nothing in that box could ever be 0. So I start going through. Here, x can't be 0. X can't be 6. X can't be 6. X can't be 6. X can't be negative 5. And x can't be negative 4. So if I put those in ascending order, negative 5 was the smallest, then negative 4. That took care of those. I had a 0, and I had 6. So add those. So those are the values that would make this expression have a divide by 0 problem. So you can see where we make sure you do the restrictions before you cancel. It would be a big no-no if I just looked at this answer and said, oh, I guess the only problem x would have if it was 0 or negative 5. And when you compare it to what the real answer is, we've actually lost 2 of the restrictions that we canceled out. So that's why you have to consider before you get to your final answer. Okay, so that's going to be it for today. So just remember, dividing and multiplying rational expressions, you do not need to find a common denominator before you combine them. You just multiply across the top and bottom. But just like when we simplified, you want to factor first and then combine and cancel factors. Okay. Now, there's one little thing I just wanted to talk about, and that's a very common thing I see, a very unfortunate mistake. So say I had something like this. Okay. I've had a lot of students in the past think about canceling, but they cancel before they factored. And actually, you can't cancel anything here. You can only cancel factors, not terms. But I do see students that will say, hey, look, I've got an x squared there, I've got an x squared there. Let's cancel them. And then they give me an answer, 2x plus 11 over negative 5. That is completely wrong. Okay. The expression that I always use is you can cancel factors, you can't cancel terms. And what this person did was cancel terms. Whereas all the questions we did, the only time we ever canceled something was when it was a factor. Okay, so that's it for today. I've got a good handout with lots of practice questions, so make sure you know how to do this, because the next lesson is going to be a lot more complicated. It's going to be adding and subtracting rational expressions, and those are the ones where we do have to find a common denominator before we can combine them. So make sure you've got this part down pat before you attempt learning about adding and subtracting. Okay, thanks a lot for joining me today, and we'll see you on the next lesson.